Welcome to the Commercial Kitchen Chronicles, the podcast dedicated to the commercial food equipment repair industry. My name is Pat Finley. I'm a lead master certified technician at General Parts Group. My goal is to shine a light on what I believe to be one of the most interesting and rewarding industries that field service technicians can work in. I love the work I do, and I'm glad you're here listening to this podcast. In this episode, I'm joined by Jason Latimer and Rich Ortega as we talk refrigeration. Welcome back to another episode of the Commercial Kitchen Chronicles. We've got Rich, El Chico Cabra, and Jason Latimer on. But first, let's get down to business. So you guys know I do RLS Press, man, and that stuff's great. So RLS Press Fittings for HVAC offer unparalleled convenience. You just press and you're done. No flames, no mess, and absolutely no hassle. Whether it's commercial spaces, residential installations, or complex industrial setups, RLS Press Fittings deliver the strength and precision you need all in one compact design. Upgrade your connections, elevate your projects, all with RLS Press Fittings. Now that's out of the way. What's going on, gentlemen?
What's going on? What's going on?
What's up, y'all?
Been a long day. Been off work the last couple of days. I'm off tomorrow. Just get some stuff
Lucky.
Yeah. You were last week. I don't want to hear it.
Yeah.
Taking some PTO?
Yeah. Well, I was supposed to go to Spessa, and then I had a contractor say get my room finished upstairs in my office. So that kind of took a little bit of precedence to make sure I'm home to get that taken care of. So I'm ready to get moved into my office, studio, and get all my banners up, my lights up, and all kinds of stuff. So it took a little more precedent over going to the regional meeting, but I'm sad I missed it. Seen some pretty cool pretty cool footage and pictures and stuff. But it's always a good time. But hey, there's always the next one, right?
Oh yeah.
So every time I see the name, I want to start laughing. So, Rich, you do anything fun today?
Cleaning up after some half-assed tech that I work with. And it goes with our topic today of refrigeration. Part of it was him not changing the dryers after changing compressors, and then has the nerve when the unit's still not working to quote a new cap tube replacement. And the cap tube wasn't even plugged up. It was the dryer. So did about $2,000 worth of free work today, give or take.
Yeah, it happens, unfortunately. I don't know why guys think they can change a compressor and not change the dryer. I mean, even if the system has a leak and it's never went negative, you still need to change that dryer. So
Yeah, exactly.
Jason, what about you?
Oh, it wasn't a crazy day. Just office work today. Didn't have to go out. It rained all day, so I didn't have to go on a roof or anything like that. So wasn't complaining. I got to get caught up on some emails and some contract work, and it's a pretty smooth day.
Nice.
Day. My team's doing their thing. They had all ice machines, so for the most part, they worked on the ice machines and their reach-ins, and then it cleared up later in the afternoon. They were able to go up and change filters and belts and clear drain lines and get back inside and go about their day. And then hopefully tomorrow, probably be about the same thing with this weather. So
yeah, it flat poured here bad. It was terrible. It was decent this morning, got pretty windy, and then all of a sudden it got dark fast, and it was just buckets of rain coming down.
I mean, we had beautiful weather up here, so just throw that out there.
Yeah, thanks.
It's coming.
Yeah, what somebody told me recently that the Farmer's Almanac is predicting that this is going to be the coldest winter coming up here. I'm not sure what that's about. I know it's hot as can be. So if there's going to be a flip side to it and it's going to be as cold as to be, I'm looking forward to that.
I feel like I hear that every year, though.
Yeah, heard there's going to be a lot of hurricanes this year because of the El Nino. The water at the beach here is 90 degrees. It's like getting in a hot tub practically. It's not even refreshing.
It's bathwater at that point.
Yeah.
So, you mentioned cold. I don't know if you have headmasters down there. We're talking about refrigeration today. And come mid to late September, sometimes October, I start getting calls, when it gets cooler at night and it's warmer during the day, of course, and at schools or a restaurant, they come in first thing in the morning and everything's running warm. The cooler's running warm, the freezer's running warm. Sun comes out, it warms up a little bit outside, pressures build up a little bit better, and all of a sudden it's working fine. You get there in the afternoon. I'm just going to bring this up because, that's what we're talking about. But A little tip I'll tell guys when it first gets cold of the year, check those temperature logs. If you have a repeat issue of it being warm in the mornings, your box, and by afternoon it gets back to normal, check those charges because headmasters start bypassing when it gets a little cold. You may be low on charge.
Yeah, I think the best thing they can do is pull the charge and weigh it back in and see what they're missing, because these guys like to add, when it's cold out, they like to add that charge. And then come summertime, we have all these high head pressures and everyone's blaming the dirty coil. But, there's a lot more going on there.
Yeah, see, I'm not really a fan of headmasters, but honestly, I'm not the greatest with them. And where we live, it doesn't get cold enough where you actually need them, but it does get to where they can act up if the charge isn't done properly.
Yeah, I just know, like, I had a school, and they put new equipment in over summer, and I showed up, like, it was like October 3rd or 4th, and I, like, walked by. I'm like, I want to see something. I walked by the condensing unit because they moved it on the ground from out inside, and I look over the sight glass, and it's flash full, flash full, flash full. And the maintenance guy's like, what are you doing? I was like, call those guys back out, tell them to put the right charge in here. I said, you're running a little low. And he's like, how do you know that? And I had to explain it to him. And the guy supposedly done HVAC for years. So, but there was no leaks. They came out and checked it. There was no leaks. They just, they charged it in July instead of, October. So
what's your method when it comes to a headmaster? What I've been doing the past couple of years, because one of our senior techs told me this is how he always does it, is so if he's charging it in the summertime, he'll charge, until you got a clear sight glass, and then he'll usually add like 2 pounds to it. And he says that usually ends up being right about spot on if he doesn't know what to actually put in the system, what it holds.
I always charge the full sight glass, and then I'll try to add 10%. And then what I do is I try to pump down my receiver and try to measure how full that receiver is, because you don't want to go above 80% of that receiver. So I try to do it that way. Now you can there's formulas to do it, and it gets kind of crazy. And you got to count tubes and bends and all kinds of stuff, and measure pipe size. But generally, I'd like to go full sight glass, like on temperature, and then add 10% in, and I'll valve off that receiver, and I'll heat it up like a heat gun or a torch slightly, and then you can feel the fullness level. If you watch Chris Stevens, he actually uses a thermal imaging camera, and he'll heat it up, and you can actually see it real well with the thermal imaging camera. It shows it really well, like where that line is, because that refrigerant will stay cold, and above that refrigerant will be hot, and you can see it plain as day with thermal imaging camera if you just put a little heat to it. Now, you don't want to go and leave your torch on there. You just want to wave it across there a couple times to generate some heat on that metal, and it shows up plain as day.
Okay, cool.
So, but you can always look up or call the manufacturer of your outdoor equipment, and generally they'll tell you, the max charge you can hold for whatever refrigerant you're using or it's designed for.
Yeah, that's my go-to.
What I was taught, and it seems to work most of the time, is and y'all tell me if I'm wrong in any way, but if you know the receiver capacity, it's usually in liters, but I believe you can do whatever the liters are times 2.2. That translates to pounds, and then 80% of that is what you want to charge to. It seems to work. The same guy that told me to charge to a full sight glass and then add 2 pounds, he was like, if you can find the receiver capacity, that's the easiest way to do it. I don't know if y'all know any different from that.
Yep. I never heard that, so that's a good one. I'll have to check that out. So Nasty says he tends to pump it down and then torch it. Yep, pump it down and put a little heat to it, and you can feel it.
Nice.
But yeah, I prefer just generally, if I'm putting in a new system, I'll either email in to tech support, or I'll call somebody like, hey, I have this receiver, this refrigerant, this is where I'm at. What's the maximum charge? And then go from there. But
that's the one thing I've never thought of.
Yeah, and I always, even if they say, oh, that's a 12-pound receiver, you can put 10 pounds in it. I'll still charge the full sight glass and then go from there.
All right.
So you've guys done a lot of installs on the refrigeration side?
Hit or miss. Just depends on the customer. I've done a lot more in the past than I've done here lately, unfortunately. I did built a box a couple of years ago, walk-in freezer cooler combo, 2 condensers, 2 evaporator systems, but it's just hit or miss, man. It's kind of weird.
Yeah, I do a good amount. Me and the same guy I've been talking about, we do most of the equipment change outs. No, I'm lying. We do just about all of the equipment change outs for our branch over here. And I mean, this year, not as many as last year. Last year, it's like we did a ton of them. I mean, we had days where we did 2-3 change outs, day, and then day. Like we did one place in 2 days, we did $35,000 worth of equipment change outs and whatnot on. First, we did the cooler, then we did the freezer. Actually, we had 2 or 3 incidents like that. So, yeah, we do a good amount of them over here. This year, like I said, slowed down a little bit, but
Always on the same site?
Hmm?
Always on the same site when you have 2 or 3? Or you multiple
no,
sites?
it can be either or. I mean, we've had several where it was like one day we did the freezer, the next day we did the cooler.
Mhm.
But yeah, sometimes it's like, okay, hey, Monday we're going to be at this location doing a change out, Wednesday at this location, Thursday at the next location.
Gotcha.
Yeah, so I do a ton of reach-in stuff. And not really change outs, but most of our stuff's inside the reach-in. We get the walk-ins too, but generally it seems like most of our issues where I'm at is the reach-ins. They're in the kitchen, they're soaking up grease, they're doors being left open, gaskets are hanging off them. That kind of stuff is the biggest issue we see in my area. Is just abuse in the kitchen, pretty much. Luckily, it seems like it comes and goes in spurts. But you got to stay on top of those gaskets. That's my biggest issue is freeze up due to airflow. So make sure you stay on top of those gaskets. Make sure they're good. Make sure they're not smashed completely. Make sure they're in the track. Make sure they're not hanging out. That kind of stuff. Okay. So reliable. We're gonna do some walk-in boxes soon. Are you building them or just putting in new condenser and evaporator? Have you guys ever built a walk-in?
I have. We did a nightmare one at a college last year, I think it was, or early this year. It was I forget what size it was. It was wide and it had glass doors and glass windows on one end. It was real nice, but what made it a nightmare was the GC that was remodeling the building. They never leveled the floor. And apparently at some point in the whole construction, the college told them they could not level the floor where the box was supposed to go. And on top of that, when I went into the site survey, it was just framed out. So I asked this GC, I'm like, where's it going? He's like, here. And he's like, you'll have 3 feet on this side, 3 feet on that side to play with it, square it up. By the time he got done, we had 2 inches on each side to mess with the box and get it square. But it took us, we spent honestly probably almost a full day just finding wood on the job site and making shims just to be able to level the box itself before we could put it all together.
How do you get those shims to stay there over time because of the temperature, the swelling of the wood? I mean, could you explain that to me? Because I've never done a build-a-box before.
I mean, that was my first time doing it, but being that they went underneath the insulated floor, I don't know that it'll be too much of an issue. I mean, if it does,
so it's not visible from. So it's underneath. No. It's not visible.
Yeah, exactly. It's
under the weight of the box.
Floor. Exactly.
Gotcha.
And then we cut them super long, so they're going from exactly wherever the floor is not level to the end of the box. All these shims were 3-4 or more feet in length.
Oh wow.
Yeah, we were basically taking like 2x4s and then shaving them down to make shims out of them.
Oh wow. Why wouldn't they let you make appropriate adjustments? They just didn't want anything messed with like that, the structure of the building?
I don't know. I don't know if it was like a historic building or what, but literally, and it was confirmed by the maintenance, the facility staff of the college. They were like, yeah, we ended up, for whatever reason, not allowing the floor to be leveled. I'm like, okay, well, y'all just screwed this whole thing up, but we'll make it work.
Yeah. Some places are funny like that. They'll like, well, we have to have re-engineered and drawings and approvals. It's just like, we just need to change some levels here and some surfaces.
Yeah. They probably didn't grind them inside the building or something by the time they got to that point of the project or something, I imagine.
Yeah, we never got the details. We were just like, oh, we'll make it work. Y'all are going to pay for it, but we'll make it work.
So Bobby says he's used 1/4-inch Durock. That's a good idea. I never thought about that. So slide some Durock underneath the panels.
Yeah,
it sounds like you're 1/4-inch out if you're having 3 or 4 foot long shims.
Oh yeah. I mean, we were stacking several shims and everything. It was insane. I wish I had pictures to show y'all. It was crazy.
So as far as inside the building, I've done a lot of chicken places. I've worked in the Lord's Chicken, as we call it around for years and years and years. They've actually started going away from them, but they had those Brandel breading tables, man, and they had a 5-year warranty on those bad boys.
Mm-hmm.
And dude, you've been in there. They're flinging that flour, that coating, or that coater around. I've had coils that were like 6 months old that I had to literally like take nitrogen at like 150 psi. You spray it down with water. You put a towel on the backside. You pull the fan off, put towels over the backside, and just blow it through, and it comes out like clay.
Yeah.
So the Chick-fil-A's over here, we actually put filters on all the condensers, so their condensers don't get that bad now.
So I've noticed here recently at some of my stores, they're putting in these little Duke ice boxes.
Mm-hmm.
There's got a little touch screen on there and it just measures temperature and tells them, hey, you're getting warm. But this is like a Duke unit. It's pretty sweet.
Yeah, I've seen a couple of those. I haven't worked on them, but they look cool.
It's got a hand crank. You can raise it lower to whoever's height's working, doing the breading and stuff. And it's pretty neat. I'm surprised they got away with those, got away from the Randell. Like I said, it's a 5-year warranty. And most of the time, they beat the crap out of it for 5 years. And then all of a sudden, they just get a brand new one. So I was kind of surprised when I walked in and seen that first Duke thing in there.
Yeah, I don't know about overall, but here I feel like those Randell tables had a lot of issues, a whole bunch of stuff. We were constantly servicing them for different things. That's probably why they got rid of them. Leaks
all the time, man.
Mm-hmm.
Them up. I mean, just other manufacturers have the same issues. It just seems like the Randell always had a leak, and it was always just at that place, dude, clogged coils, man. Pizza places, reliable. Adrian said pizza places are the same way, and it's crazy. Anywhere that has flour, it's just a recipe for disaster. So it looks like Bobby wanted to know what you are using for filter media. So what do you use?
I just literally messaged back on there. I've got no idea. Our PM crew does all of that, so I'm not sure exactly what they're using.
You haven't seen that blue horsehair stuff or that? So we have 2 different ones we use. We use like some blue. It's like 1.5 inches thick, but it's like pretty much nothing. You can squeeze it down to nothing. It looks kind of like the blue, like 1-inch cheap furnace filters, and then we use some like gray spongy material. But nothing's really going to catch that flour. I mean, it does a little bit better job, but it still gets pretty beat up.
Yeah.
So, yeah, Lee brings up a good point. Those breading tables, man, they rip those lids off there. That big long hinge, like that 6-foot long hinge you got to put on there and spring loaded. Have you had to do one of those?
At the Chick-fil-A?
Yeah.
Yeah, that was one where one of the times I had to work on the lids is like the hinges broke. One of the bolts broke and it stripped out. The hole stripped out where the bolt went and all that good stuff. So I rethreaded it, but it was funny because it was my first time seeing one. So I had no idea how to open that lid. And the ticket just said something like the bracket moves when the lid opens. So that was one where I tell y'all that I'm like, go ahead and show me where you're having the issue. I had no idea how to open it. I said, dude, show me what's going on with it. And then I watched the guy open it. I'm like, all right, cool. I got you.
Nice. So Brian asked, what are our thoughts on Husman reach-ins? I don't have any Husman reach-ins. I had a set of 4 8-foot-long Husman open-air cases, and we ripped them out after 3 years because they installed the condensing units on top, and then they finished the ceiling around them. So you had like a 12-inch opening to get in there to service them. And they were all sealed up, so it just kept eating compressors left and right. That's when I was talking about that one time where I measured like a discharge temperature of like 300 degrees after the compressor. So that compressor just smoked. And one section would run all right, but as soon as you got further down the line and more airflow, they just die, dude. I literally changed the compressor, and like 3 weeks later, it was gone again. I'm like, guys, we can't keep doing this. I mean, I don't know how much money you're paying us, but it's not worth it, man. And they brought in engineers, they brought in the building engineers, the college engineers, and everybody like, oh, that should work. I'm like, no, it's never going to work. I had like 10 different temperature sensors up there, and I was like data logging everything. I'm like, look, this is ridiculous. This thing can't run. You pull the covers off and it runs, but as soon as you put these decorative panels back up, skyrocket. It'd kick high pressure switches. It'd kick out those little thermal overload, sensors they put on the discharge lines and stuff. And then I got there one time, and one of the guys had moved the thermal overload switch. He just like took it off, so it was just hanging in the air. I'm like, what's the point, dude? Like, you wonder why you can't keep a compressor in this thing.
Right. I want to say I've worked on a handful of Husman reach-ins, but old ones, and those were pretty solid looking. mean, probably rare that I ever had a major issue, but those were the ones with like the old Coplamatic compressors and pretty much built like tanks. You could probably set off dynamite inside of them and they probably wouldn't even dent. But I haven't worked on anything newer, so I couldn't tell you.
Everybody's digging the name change. It's great. So, in our world, that was derailed. It's derailed bad.
Oh man!
In the kitchen, these companies, they got to PM their stuff, man. There's no ifs, ands, or buts about it. In the kitchen, whether it be flour, breading, grease, lint, you name it, it's in the kitchen. They have to clean these. Whether they do it themselves or they have an agreement, but if you do not clean your equipment, it's going to die. I don't know what else to tell you. Inside joke on the name. Yeah. Yep. Condenser coils keeping each other warm. Yeah, they were. So those Hussmans, they were weird because the discharge, there were 4 units. There's actually 2 condenser units per unit, and the way they were designed was they discharge air into each other from the back, so the coils faced out away from each other. And but the problem wasn't there was 8 compressors up there, and it just blew that air around, dude. They tried putting in return air ducts, but then they'd shut off the AC, so it quit sucking the air out. It didn't make any sense whatsoever.
Yeah. So Pat, I want to hear you talk about something. It's something that I do, but I feel like you probably can give a better explanation on it than me. But I know you do a lot of non-invasive charge testing. You know, testing the charge without hooking up gauges. Which, for anybody out there who's not, very familiar with refrigeration, or even if you are, my thing is gauges should be your last resort. You can get a good idea of what's going on inside the system without connecting your gauges, and you don't want to connect your gauges unless you have to, because every time you connect your gauges, you are losing some charge, especially if you've got the traditional manifold with the long hoses like that. So learning how to test the charge without hooking up your gauges is pretty critical, in my opinion. So go ahead, Pat. You explain that for us if you can.
So what I do on the non-invasive stuff, so generally it's anything critical charge. Nowadays R290, R600, used to be R134. There's still some R404 stuff. Anything they don't want you putting gauges on won't have access fittings. So say if you walk up to a cooler and it's running warm and you start your diagnosis process, how I like to do it is I measure box temperature inside. I measure, ambient temperature outside. I measure temperature exiting the condenser fan motor. I get crazy with measuring. I measure discharge temperature 6 inches from the compressor and out. I measure suction temperature, either if I can't get it at the coil, I get it coming back out the wall. And then I measure liquid line temperature. And you get to know your refrigerator type, and you can kind of get in the ballpark and see what it's doing. Once you get all those, and you think you may have a leak or whatnot, I check the amp draw on the compressor. So if you have a leak, you're not going to be pumping as hard, so your amp draw is going to be low. And generally, that's enough information to figure out, hey, I have an issue here, refrigerant charge, and then you can go ahead and if it's warranty, I always call the manufacturer and ask, hey, this is what I found, this is what I got as far as discharge, suction, liquid temperature, ambient temperatures, that kind of stuff. And give them all the information. Most of them, yeah, go ahead, you got a leak. Go ahead and tap it, put some gas in to find the leak. Outside of warranty, you don't have to ask for permission. Just go ahead and put taps on and go from there. But generally, like I said, measure about every temperature you can think of to measure, and check an amp draw. If you got low amp draw,
what do you look for temperature wise? Because I do it kind of old school. What are you looking for temperature wise when you check like the discharge and all that stuff?
You'll have a warm suction, you'll have a hot discharge, and then liquid will probably be pretty close to suction. It really does not much change in it. It may be a little cooler, but generally that's what I look for.
So you're not looking for any specific temperatures based on the design temp or anything like that?
It's just based on refrigerant, so I'd have to look at a scale. I can't remember temperature pressure chart off the top of my head, but generally your suction will be close to ambient, and your liquid will be close to ambient too. Your discharge may be a little higher, could be high. It just depends on what's going on in the system, how low it is. So it can be completely flat, and then go from there.
Yeah. See, I do it a little old school, and I didn't know if you knew anything about temperatures because I had somebody ask me, well, what temperature do you look for? And I'm like, look, this is how I do it. it's basically what Pat just described, but my discharge line should be scalding hot.
Yep.
The entrance to my condenser should be just about scalding hot, and it should gradually work its way down to ambient temperature, more or less, if I'm touching my way down the elbows down to the liquid line. And your suction line should be pretty cold. I mean, that's how I do it. That's why I say I do it old school, and anybody watching could feel free to pick that apart, but it doesn't fail me, and it it works for me. So I just wondered if you had specifics on that.
No, I just measure temperatures and try to go off the temperature pressure chart, and you can tell. But generally, if it's close to ambient, you got issues. And most of the time, I just have the temperature readings so I can go to the factory and verify, hey, this is what I've done. Because a lot of times they'll want them under warranty. If you don't give them the temperatures, they're going to be like, oh, you need to get temperatures. So I just kind of like little CYA, like I said, cover your ass. But because if I'm by myself and I know it's got a leak, I just start feeling around. And I can pretty much tell by its act, and then I just check Amtrol. But if I'm doing it by the book, if I'm teaching somebody, I measure all temperatures, make sure that they see it.
Yep, I like what Reliable just said there too. Yeah, a good sign of a low charge when you have an expansion valve, at least, is a hissing evaporator, or your metering device is frosting up too. Those are also good indicators.
Yeah.
What's your procedure? What's your basic procedure when you, and it's either one of y'all, Pat or Jason, when y'all get up to a location, box it, it's a reach-in cooler, but it's running at 60 degrees. Walk us through how your guys are going to normally run that call, how you're going to perform your troubleshooting.
So for me, I just go in there, I check the airflow in the evaporator, check the airflow of the condenser. If there's a site class, I peek it, if there is, if I'll check if there's any frost on the evaporator, I'll check if there's a data plate, and I can get an amp reading to compare it to the data sticker. I'll do that. And if everything's closed, the gaskets are good, there's no moisture getting in and things like that. If I need to, I will verify if it's running, and if it's not, the thermostat's not stuck, what kind of programming it's on, if it's at the set point, if the probes are in the correct place, and then last but not least, I'll gauge up if I have to gauge up.
Nice.
First thing I do is, like you said, check airflow. Check your evaporator coil. I always open it up. Look at the fan. Try to shine a flashlight back in the coil so I can see the coil, if it's frosted up or not. If I can't see it, then I go around the backside. On these reach-ins, most of the time that coil's on the ground, and 95% of the time it's got a glove or a piece of wax paper sucked up on it, or a baggie, or full of dirt. So I like to brush that off, and I'll shine a flashlight through there. If I'm not getting light through there, I'm not doing anything else until I can see a flashlight through there. So that's what I'm going to do. I'm going to get my cleaner. I'm going to get a brush. I'm going to get, nitrogen. It just depends on what it is, what's near it depends on how I attack it. A lot of times you can just, if it's just, say if it's like a Starbucks, there's no grease in there, you can just use a little bit of water and blow it out, and it's pretty good.
Right.
The kitchen, you're going to have to use some sort of chemical. Just whatever you do, make sure you rinse it out 100%. A lot of guys think that evap no rinse is good for, says it's good for condensers, but the problem is you still have to rinse it off, because the way it's no rinse in an evaporator is that evaporator is pulling the moisture out of the air, and it clings to the coil and it runs off. So it's self-rinsing that way. But your condenser coil doesn't pull condensation out of the air, so it's never going to self-rinse. So you can use it to clean a condensing coil, but you need to make sure you rinse it off, though. And then once I get air going through there, I give it a little bit of time. I start measuring the temperature, see what it's going to do. And if it starts dropping, hey, it was a dirty coil. Like Jason said, check your gaskets. Make sure your door closes properly on its own. Most of these reach-ins, you should be able to let go of that door and it should close, just to hold stuff closed. Whether it be magnets in the gasket or the hinges, got the levers.
Cams.
Yeah, cams in them. So most time doors should stay closed on its own. If all those things are working and it starts working, great. If not, that's when you're going to start checking Amtrol and go from there. Check your controller set points and all that good stuff.
Adrian mentioned the noise, and this normally I only catch that noise in walk-ins, and it's normally for me, I've never heard that noise with regular TXVs. I've only heard them with EEVs,
Really?
the 404s. Yeah, I've never, I guess the audible noise is so much louder for me with the EEVs. I'll put my after I do the normal check, I'll check the computers for like the master builds, and normally the superheat's up there in the 80s and the 90s, and I make an adjustment and bring it down, and it starts to quiet and it meters, and then I compare it to my digital gauges. But again, I've never heard that audible sound other than with those EEVs.
Nice. What would y'all say the most common mistakes, like when y'all run by another technician, either from another company or even from y'all's own company? What are the most common mistakes that y'all see being made when technicians work on refrigeration?
People just not checking airflow. They're assuming that it's high head pressure when one of the fans are out, or they're running slow or backwards because of a bad capacitor. Low pressure and not checking the belts, the tension of the belt and the speed and whatnot. Not checking for clean coils, and all that to say that they're adding or taking away refrigerant instead of checking those basic things, which are more, I think, especially the condenser and the condenser fans are, with this heat, they're affected by this heat badly, and you need to maybe get a refresher and clean that coil. It might have been a few months since the last time it was clean. Blow some dust off of it, check those fans and stuff like that. Even check the amp draws of those fans, and maybe the capacitors, they might be out of capacitance and not charging, getting them going to the speed they need to. And then I found fans running backwards because the capacitor's done, and people just assume that they're bad. So
yeah.
What was Adrian saying?
Dirty coils, and he said not checking high side if you have gauges. Yeah, I get it all the time. So a lot of people don't know is that those condenser fan motors are actually supposed to be cooled by the air pulling through there. If you have a dirty coil, it'll actually kill a condenser fan motor.
Yep. Yeah. It struggles. It pulls the amps, then burns them up.
Yeah. So if you change a condenser fan motor, check the amperage of the new one and make sure it's not running high amperage, because if it's not getting proper airflow, change it. I was listening to the Advanced Refrigeration podcast, and Kevin was talking about cleaning coils. He said if you walk up to a condenser fan motor and it's blowing air out the side around it and not through the coil, he said right there is a dead giveaway that you got packed coil. It may look clean, but if it's not blowing air in the right direction, it's dirty. So I learned some stuff from those guys. Those guys are very pretty smart.
I tend to notice too, when you got a really bad coil, especially on a walk-in, but it really applies to everything. There's an insane amount of heat that you'll feel radiating off of that condenser because you don't have that airflow. I walked up not that long ago. Me and my trainee walked up to a unit, and I'm like, "Oh, this coil is packed." And he's like, "How you know that?" And I told him, I said, "Come stand back here where I'm at." I'm like, "You feel that insane amount of heat?" And he's like, "Yeah." And then he took his flashlight and he was like, "Oh crap, this thing is horrible." It took us, I think an hour and a half to clean that condenser. That's how bad it was.
Most guys want to jump to conclusions. They want to check charge off the bat. That's the last thing I want to do, man. I will spend an extra 15 minutes being lazy to avoid checking. I'm checking everything but the charge. I don't want to do that. I don't want to hook up to that. I don't want to touch it. I want to check everything else first. Some guys, that's the first thing. And that's the reason why these small units don't have access ports. It has nothing to do with it's R290 is flammable. That has nothing to do with it. It's a critical charge. They don't want some guy going in there and throwing a hose on there very first thing without checking anything else and blowing the charge. Because guess what? If you have a 3-ounce system and you throw a 4 or 5 foot hose on there, you don't have 3 ounces. You're done.
Yep.
You don't know what you walked into because you screwed the charge off the bat.
Yeah, I very rarely actually connect my gauges, and by the time I do, I'm usually confirming what I already thought the issue was. I know there's a lot of resources out there online and on YouTube that'll explain in depth how to not hook up your gauges and still check the charge. And I think that's something that a lot of people in our industry need to learn. I walked in one time. I think I was bringing parts to another technician. He was working on an ice machine. It had nothing to do with the refrigeration. I can't remember what he actually changed on it, and he still had his gauges on it. And I'm like, why in the hell are your gauges hooked up right now, bro? Oh, well, so-and-so told me you should always know the pressures. I was like, don't ever again in your life hook up your gauges for a non-refrigeration related issue. I'm like, the amount of times I've actually had to put my gauges on an ice machine versus the amount of ice machines I've worked on, I've almost never had to put my gauges on it if you were to do percentage wise.
Yeah, I tell my guys, it's always assume it's mechanical first.
Yeah.
Never go popping the system open. Mechanical, there's probably the charges. If it's been running this whole time just fine, there's probably a solenoid not opening up, the sensor not working, probe not working. There's normally some sort of moving part or something that's active that's probably failed. So always go through those things first, and those are normally the easy things to change out. A ice thickness probe, a bin switch, thermistors,
Right.
controller button stick, power buttons break. It's just go through your sequence of operation, and the last thing you want to do is play with the refrigerant.
I always tell everybody refrigeration is 95% everything but refrigerant. I mean, whatever gas is in there, it's generally electrical, other outside factors, ice machines you add in water and that kind of stuff. It's generally 95% has nothing to do with the charge. It's something else causing all the issues, I believe.
Adrian just brought up a good point. There has been some instances where you got it. There's been some instances where the AC is not working, and in certain rooms, and or these the condensers on top, and it's the heat rises, and they're all starting to struggle. That's a really good point. Sometimes you'll find a unit in a room and whatnot, and it won't work right, and it has a lot to do with the AC being down. And I've learned that when I first got in, because I'm just doing everything to this machine, and just to find out that it's hot as hell in here. I'm not noticing that because I'm new and I'm stressed out and trying to figure stuff out. But that's a good point.
That's a huge point. Because one thing I'm learning, because I'm not really an HVAC guy, but I'm learning HVAC being here at Whaley. And a lot of times they'll call in, the AC's not working, the kitchen's hot, and it's like, actually your makeup air is not working. It's not the AC. It's you got your ACs are working fine, but your makeup air is not working, and your exhaust is basically sucking out all the cold air. And a lot of times you can go to the exhaust and you'll feel straight up cold air coming out of it. So yeah, a lot of times you have to look, every time you have to look for possible external issues that don't even have anything to do with the units.
Yeah, there's, someone said there's something the other day about, refrigeration's harder because there's so many outside factors besides the unit itself. I think, last week, I think someone brought that up. A kitchen, it's easier to mainly do kitchen work because it's not affected by outside factors. But, refrigeration, if it's too hot, it's too cold, I mean, everything plays hell on it. So you guys do any open air cases like grab and goes at like gas stations or any other place uses like Structural Concepts makes a bunch in my area because they're in Michigan. But
I do not.
So
I've worked on a few of them, but I don't know. I feel like I get lucky with them every time I work on one of them.
Yeah, the few times I do, it's normally something like a drain line's clogged or a mechanical thermostat is stuck or something like that. But I've never had any refrigeration issues per se in a case.
Most of mine aren't refrigeration issues. The drains, because they run a ton. They're real susceptible to ambient conditions. So I was just going to say, if you work on a lot of open air cases, the first thing a lot of manufacturers want you to do before you even do anything is look and see what's around there in the ceiling. Look and see if you have a heat duct blown down on there, an AC duct blown down on there. It's pretty key to a lot of these things that, they don't have AC or heat ducts blowing blasting right in them. It causes a lot of havoc. So I was just going to say, if you work on a lot of those, make sure you check air from blowing in there.
Yeah, and one of the things I would say I have noticed, and it was probably most common in this chain that I used to work at when I was in Orlando, they did like fresh pasta and stuff, and they had all the vegetables in an open air case, and those vegetables just drop beneath the pans and whatnot, and you end up with a ton of vegetable, lettuce and spinach and all that stuff blocking the condenser. So I actually got in the habit where if it is a cooling issue, one of the first things I do if there's any kind of produce in there is lift up the pans and look to see what's underneath there, and then wash it out. And a lot of times that's a big issue, just stuff falling down in there.
Yep. So Stephen Bress, this is a new name here. I appreciate you joining, Stephen. He said gets that a lot with people keeping fridges in the garage in the summer, then no freeze in the winter because most top line units use refrigerator compartment temp control for the compressor and just size the freezer stays frozen when the fridge is running normally. But in the winter, the garage temp control below the fridge temp, so it turns on and the freezer defrosts. I never thought of it that way, man.
This must be up north.
Yeah, must be up north.
Yeah.
It happens in Indiana, I bet. Luckily, my garage freezer is a commercial grade freezer and doesn't have a refrigerated section, so I'll be all right.
That's good. That's good, Steven.
We got Ben Poole in the house. Thanks for joining.
Ben Poole's in the
Oh, snap.
house.
Look
I
at
just
us
got
moving
my
on
tickets.
So yeah, I'm looking forward to AHR Expo. That's what Jason's referring to here. So
Nice.
what else we got? Honeycombs get dirty and don't move enough air. So you're talking about the open air cases. So the open air cases work kind of different. So most the evaporators are on the bottom, they suck air in, they create an air curtain. So they got a baffle that runs at the back and it'll have slots cut in it for air to go out to the shelves. But then in the front and the top, there's like a little honeycomb black plastic piece jammed in there, and it actually blows air straight down and it creates an air curtain effect. So it's supposed to roll the air inside the case and kind of act as a curtain to keep, outside air coming in. But those curtains get blocked up, and then like everything else, it just causes havoc.
And another thing too with those air curtains, correct me if I'm wrong because I could be totally wrong. I know for sure this happens with a lot of bar equipment, but I believe a couple of air curtain manufacturers have told me this too. You're supposed to put pre-chilled product in there. You're not supposed to load room temp product. Is that correct?
Yeah, you want to put pre-chilled in there, and that's pretty much for any reach-in. Most manufacturers don't want you to put cold stuff in there. It's not designed. It's designed as a holding cabinet versus a chilling cabinet. So, yep.
But yeah, like you can get away though with most reach-ins putting room temp stuff in there and it'll get down. But like I know, going from air curtains and talking mostly now about bar equipment, I'll have customers that'll sit there and they'll have all their beers room temp because they don't have anywhere to store them, and then they're like, man, this cooler never works. I'm like, you're doing the exact opposite of what it's designed to do, and then you have to pull up manuals and stuff like that explaining to them that these are designed to hold product, not to actually chill product. So that's another thing I think a lot of people miss on a lot of refrigeration, especially the smaller units, is what temperature is the product you're actually putting in there to start with. If you've got a customer that's putting room temp product in a boiler and an air case, that's going to be your first step, is to have them start putting pre-chilled stuff in there.
Yep. So, Reliable's preaching, what we were preaching the other night. You got to make sure you train your customers so they know how to operate their own equipment. Most customers, they think you just plug it in, throw stuff in there, and it's good to go. And it doesn't work that way in a lot of cases. There's a lot of variables. And like you were talking about, put a pre-chilled product in there. If you throw a hot product in there, it may eventually come down, but it's going to take a long time.
Mm-hmm.
So, Adrian, people get away with undercharging walk-ins here until it gets freezing once every 5 years. It's free. That dude's like down on the border pretty much. If it gets freezing down there, it's going to be a rough-ass day.
But yeah, people are big on undercharging walk-ins. I mean, when you're charging up a walk-in from scratch, aside from just adding charge to it, making sure you got a clear sight glass, you still need to check the superheat, make sure where it needs to be. There's a lot to it. A lot of people think, oh, let me just throw some gas in it. My pressures look good, my sight glass looks good, and let me get out of here. Yeah, that might get you by, but it's not going to do the job right.
Yeah. So I don't do a whole ton of electronic expansion valves. I've done a couple. It was pretty cool because you just set your gas, your temperature, and it pretty much it does everything itself, But as far as setting superheat, freezers I like to go 4 to 8, and coolers I like to go 6 to 10. That's outlet of the evaporator.
Yes, that's important. That's where I like to take my superheat, is at the evaporator outlet.
Yep, evaporator outlet. And then I always check it at the compressor too, at the condensing unit, just to make sure I'm not, you don't know what's going on, but I like to be 100% sure that I don't have any liquid going back to that compressor. So just to verify it back there. If it's a new install, you did all new line sets, you should be closer to 25, 30 once you're back to the compressor, and that's perfectly acceptable. There is a maximum allowed superheat back to the compressor you got to look out for, because, you are cooling that compressor with that cool gas coming back. So, you got to make sure.
I'm glad you pointed that out. I actually learned that from Brian. Was it Brian Orr at Kalos, listening to his podcast? I never knew that, but yeah, I learned that years ago. You've got a maximum cool return gas temp. I think if you look up the specs on the compressor, to tell you like return gas temp or something like that, and it's got to be that or lower, or you're going to burn up the compressor.
So what apps are you guys using when you're doing refrigeration repairs? I use
the Dan Foss.
there's a ton of great apps out there, man. For my gauges, I use Measure Quick or Field Piece app because I have Field Piece probes. I used to use Measure Quick a lot more, and then you start getting in trouble for doing screenshots. So I quit. I use it when I use it sometimes, but I like to take screenshots as I have it for my personal record. I'm not giving it to a customer. I just like to have it, if I'm doing notes or if I'm comparing stuff. And now if you take a screenshot, it like kick you off, so you can't be screenshot.
Oh, really?
Yeah.
What's that about?
Why is that?
Proprietary or?
Well, people were doing it and putting in like logs for get their customers. This is how the unit's running, show it, and they have a feature where it can actually tie into like a work order or something. And I think it's a pay side of it, and they just don't want you to screenshot.
Oh, it's about money.
I'd rather see them sell ads. I'd rather sit through an ad and be able to screenshot something and they have to pay for it.
What's the name of this app?
Measure Quick.
Measure Clerk.
Measure Quick.
Measure Quick. Oh, okay.
Yeah. It works with all the digital gauges, and it works with Testo, Field Piece. It works with all of them, and then it's got some pretty cool features on there. And what they've also designed it to help you troubleshoot, so you can input, BTU, CFMs, everything. You can use it for measuring airflow, and it actually helps point you in a direction what to look for. But unfortunately, it doesn't really do a really good job of that as far as the refrigeration side. It's more of an AC side. But yeah, I use the Danfoss app. The Copeland app is a blessing for Copeland compressors because it breaks down everything that compressor is supposed to see as far as amp draw, temperatures, all that kind of stuff, parts. Tells you the oil, refrigerant types. I mean, it does. It tells you the applications. It does everything.
I love the Copeland app. It'll also tell you if a compressor is obsolete, and it'll tell you the replacement for it. Yeah, that's a great app. I pulled up my phone real quick just to see what other apps I use. Yeah, the Danfoss refrigeration tools. I got the Copeland app. I've got the Embraco app. I've got the Tecumseh app. I haven't used that one lately because I don't have as much Tecumseh up here as I did when I was down in Florida. And then I also use the Heatcraft app. Heatcraft app is pretty great. You can find just about any part that you need as long as you got a Heatcraft serial number. And I'm opening it up now because I think they have a box load calculator. Yep. Yeah, they got a box load calculator, cross-reference, parts lookup, energy savings calculator, PT chart, everything in there. So that's a really good app too.
Yep. I'm all about an app to make my job easier. Now, I like the information. That's what I like is the data you can get from that. Yeah, you still got to know how to use the data, understand the data, but it gives you more what to look for. And like you said, say if you're checking a Copeland compressor and it's a sealed system and you got low amp draw, you can go to that like, oh, the amp draw is supposed to be 4.3 and I'm pulling 2.7. I'm probably undercharged here. That's going to be just another tool to use to confirm your thoughts. But there's a ton of them out there, man.
Oh yeah. What about you, Jason? What do you use as far as apps?
I got my Copeland mobile, my check charge. I use HVAC schools, not for checking charge, but for my team. There's a lot of good information on there. And then I used I found I was working on some reach-ins, and the Danfoss was helping me actually tell me to turn where to, put the information in, and tells me to actually turn on the TXV and make some adjustments. So I thought that was pretty cool.
Yeah,
it's been a little hot minute since I've been working on all this stuff. So a lot of these apps keep reminding me that they're dormant. So
let's help our boy Adrian out here. A good one, guys. Jobber, use my link for discount. So if you guys are interested in Jobber, talk to Adrian. He'll hook you up, man.
Yeah, when I get my contractor's license, I'll use that link. Okay.
You ever use the magnetic tool from Danfoss? Either one of y'all?
Yeah, that's pretty cool.
I haven't.
Yeah, that's pretty cool.
So I used to have the one that was on a keychain, like you just hold up to a motor or up to a solenoid and just spin. But they got it on the phone. It's the same thing. You just hold it there. You're like, oh, this is cool.
Yeah, it is.
So this guy's killing it tonight. The graphing function was nice when diagnosing LG refrigerators. They used to get partially restricted condensers due to oil buildup burning out when they'd run the compressors on low speed constantly. If you turn one off and watch the pressures equalize, you could sometimes spot a partial restriction as a point where a high side pressure flatlined while the low side was still climbing, and then would continue dropping. The flatline was due to the refrigerant traveling through the restriction. That's good to know, man.
Yeah, I don't know crap about residential, but that seems pretty cool.
So I actually was on a podcast this morning with TK Cousins. He runs a group on Facebook, and it's mainly residential guys, man. But I got invited in there by a friend of ours. What's his name? I can't remember his real name. He does a ton of residential repairs, but he's all over TikTok and Instagram. He invited me in there because someone was talking about switching from residential or trying to start doing commercial jobs, and he brought me in there, and it's a pretty cool group, man. I used to think that the residential guys were just like, yeah, I'm not trying to be mean here. I just thought, I'm a commercial guy, they're a residential guy, they must be hacks or whatever. And dude, some of the stuff these guys have to work on, these inverter driven compressors and these fridges and stuff. I'm like, man, I wouldn't want to deal with this crap. I mean, it's coming, but I don't want to deal with it.
Dude, that's been my thing, and I feel like commercial refrigeration, at least like on the reach-in side, is way more simple than the residential side. And I've told people that, and they're like, no way, but this is commercial. I'm like, yeah, but there's literally nothing to this unit. I'm like, I don't even work on my own refrigerator at home. If it goes down, I call somebody.
People always ask me,
or it's going in the trash.
People always ask me,
Yeah.
But yeah, they asked me like, what's the difference between residential and like commercial? I'm like, well, if I want to work on an oven, I can pull one panel off. If you want to work on that oven, you got to pull off like 5 panels to get to what I got to get to. I was like, no.
Exactly.
What we got here? Yeah, residential appliances are now way more complicated. Yeah, man, I've done a little bit here on my house. I have a convection fan that went out on my oven, and it was a nightmare. I'd rather change the convection fan on a rationale than the one on my residential stove. It was that bad.
Ooh. I think the most I've done residential, like for myself, is change like an element on an oven or on a dryer, and maybe change a belt or something like that. Aside from that, nope. Calling somebody, they can have it.
So Brian brought up a good point here. He said he used his smart temp clamps today to measure temps across the dryer. He thought he had a restriction. That's a good point to make. So if you have a restriction in your system and you're trying to find it, the best way, like he just said, is to check and measure, temperature in and out of like a dryer. I go by a rule of thumb of generally like 3 to 5 degrees across the dryer. Temp drop is probably going to get changed because you got a restriction in there. I don't know about you guys, but that's just what I tend to look at.
Yeah, see, and that's funny because I was going to ask you that because I had a situation where another tech, he thought the dryer was restricted and he had an 8-degree temperature difference across the dryer. So I'm like, I would say, yeah, change the dryer. But then my supervisor was like, no, 8 degrees isn't enough. So you're saying 3 to 5 degrees?
No, I generally do 3 to 5. Anything under 1 to 2 is pretty acceptable. Anything above 3 to 5 is what I would consider to change it. I mean, that's just me personally.
Yeah, that's pretty high. I was like 8 degrees. I'm like, that's a pretty significant drop. My supervisor was like, nope, that's not it. So I'm like, well, I mean, you the man, you the boss. So whatever you say goes. But let me ask you this. Do you
recall what happened?
I don't know, because they ended up sending another tech to go finish the job, and that other tech didn't really run it by me to tell me what he ended up finding. I was all for changing the dryer though. No, I'm lying. Now that I think about it, the tech that went back there said that the condenser was dirty was the issue. But I'm like, I know when I was going through it with the technician that was there first, he put a flashlight through the condenser and everything, and he's pretty thorough. And if he skips any steps, by the time he calls me, we make sure we go through everything. But as far as I know, that's where it ended. I don't know if that actually resolved it or what, though.
I hate that, man. You get involved in something and someone else goes and finishes it and you never hear back. I'm bad. I will literally go and like search that call out, and then I'll read the other person's notes. And if their notes aren't up to par, I'll be like, I'll call them like, hey, you're finishing my job. Do a better job with the notes. I want to know what was going on with
it. Yeah, I've done that. And I'm like, hey, do you mind walking through your reasoning? And they're like, no. I'm like, okay.
I try to do my notes in a way that you understand my reasoning and everything. If you read my notes, you rarely have to call me to find out what we're thinking.
That's how it should be, man.
Which we're going to do an episode on that, I'm sure.
I'm looking forward to that.
We need to. I don't want to beat some guys up over notes.
So which one of y'all wants to explain? Because this is another thing I run into. I'll constantly ask technicians, what is the point of pressures? And most technicians look at me confused as like if I grew another head out the side of my neck or something. What is the point of pressures? Which one of y'all wants to break that down?
Pat, you want to go on that?
So the point of pressure is it gives you an idea what's going in there. You got to be able to take that pressure and convert it to temperature. I mean, the pressure is just like, if you can't measure the temperature inside that pipe. So you take the pressure and you can convert it to a known number, and that will give you temperature, say saturation temperature of your coil or whatnot. Is how I interpret it. Now I'm sure you got a totally different reason, but you're going to give it to us, I'm sure. So
No, that's exactly it. You don't know the temperature inside that evaporator or that condenser unless you know the pressure, and then you can convert that pressure to a temperature. But aside from that, pressures are irrelevant. Like, guys will call me like, yeah, I have this pressure and that pressure. I'm like, okay, I'll tell you what temperatures those are.
yep.
Oh, what do you mean? And then I got to break it down to them. We need to know what the temperatures are in the evaporator and in the condenser, and then compare them to the box temp, and then compare them to the ambient temperature around the condenser to get an idea of what's going on. Just saying I've got 25 and 250, that don't mean crap. I mean, I don't. I mean, it sounds weird, but I don't, for the most part, memorize what pressures are quote unquote supposed to be, because there's too many factors involved when you just say, hey, I got this and this. Okay, well, what's your box temp? Is your box temp 30 or is it 65? You know what I mean? Are you running an expansion valve? What's your ambient temp? Is your ambient temp 75? Is it 105? Because like I was just explaining to a guy, I think yesterday or maybe earlier today, your pressure, you can be undercharged in an expansion valve system, but quote unquote look like you have a good charge because your pressures are quote unquote reading right, but it's because you've got a hot box and you're doing a hot pull down. So your expansion valve is wide open, which means your pressures are going to be running, high, but they're running normal. And it might sound confusing the way I'm trying to explain it, but if your expansion valve is wide open, your pressures are going to be higher. So if you're doing a hot pull down, say on a walk-in, if you're charged properly, your pressures are going to be looking like they're through the roof until the box gets closer to temperature, and then the expansion valve starts, regulating the way it's supposed to. So yeah, I always try to tell people, don't worry about the pressure per se. What is that? What does that pressure correlate to on temperature? And then what is the box temp and what is the ambient temp around the condenser? So yeah, I mean that's exactly it. It's what temperatures are running. Now, on evaporators, what do you look for as a rule of thumb? Evaporator temp versus, let's just say, target box temp. What should the difference be?
I look for around 10 to 15. Just depends on the refrigerant type and what the environment is. I don't have to be 10 degrees below set point of the box.
Yep, exactly. 10 to 15 is what I look for. What do you do on condensers, on condensing temperature versus ambient?
Well, I mean, it's a little different now with the new coils, but I try to run if the coil's clean, everything, I try to get 20 to 25 generally on the newer style coils. The older ones you could go closer to 30, but right now I try to run 20 to 25 degrees.
All right, cool. Yeah, that I was wondering, because that's a debate I got into, because I was used to generally 30 as a rule of thumb. And for me, I think, because I am learning, I have to kind of look at things a little bit different being in a cooler climate. Mm-hmm. Florida was so dang hot all the time. And I'm sure, Jason could probably attest to this. You got to kind of shoot for higher head pressures just to make sure you got a enough of a gap to reject the heat at the condenser. But yeah, I try to anywhere between 20 and 30 is what I'm aiming for on a condenser.
Yep. So what else we got in here? So Brett, 10 degree temperature drop, SST versus box temp. Yep. What else we got in here?
How long's Brett been in here?
He just joined a couple minutes ago.
Oh, okay.
He must have got his Crocs changed and jumped on.
He just joined and he's coming with the answers. That's what I'm talking about.
This dude, man.
Oh, Brett will have him.
Brett is like one of the smartest guys I've ever met in my entire life. He won't claim it. He won't admit it, but the dude is a freaking genius, man. If he can't find it, he knows where to find it pretty damn fast. So he saved my ass quite a few times. So Quentin Webb, he says exactly. He had a compressor change out the other day, 94 degree box, pull down. So yeah, higher pressure until you got down to the 30 and below. Yep. When it's pulling down hot, man, that TXV is wide open. It's just pumping gas through there. Brett says he just got home. Building some crazy training modules and stuff, man. He's killing it down there.
Nice.
So Stephen, Brett's again, for residential fridges, pressures help for figuring out what your failure is. High side leak versus low side leak, inefficient compressor, occasionally restrictions, but you never want to check pressures first. Nope, it's the same thing in commercial. Pressures are the last thing you want to check. You got to give that system every single opportunity you can before you condemn a charge or something along those lines.
Yeah, and just another random point I want to throw out there too. When you clean a condenser, fire the unit back up, you need that condenser time to dry before you analyze what the pressures are. Your pressure will look low when you have a wet condenser. So I usually give, depending on the ambient temperature and all that good stuff, a good 20 minutes or so of the unit running, dry off that condenser completely before I'm judging what my pressures will look like. I've seen guys, clean the condenser and then, it's low, add charge, and then before you know it, they're 4 pounds overcharged because they didn't wait for the condenser to dry.
It'll dry pretty fast here in Florida. It's just hot.
Yeah,
you'll see it evaporate very quickly.
I've seen someone turn on a microchannel coil that's wet and it won't flow air.
Well, if you smack it lightly, you'll pull the water out of it and just run your hand on it.
You want to tap it or something to break that?
Yeah, tap it and it'll start popping out.
So much surface area, man, it'll actually trip high head pressure. If you turn it on.
I've had that happen.
I don't know if I've ever seen that.
Dude, the first time I seen it, I freaked out, dude. I was like, I just cleaned this thing. Water on the backside, no air coming through, man. It's just holding water.
Some restaurants, the water that's going up to the roof, you'll notice in some burger places, in particular McDowell's, that they have by their water heater, you'll see an old school, looks like a shower head, like a faucet you can pop out and turn left or right. That's actually going up to the roof. And a lot of times it's set to hot water, like it's blazing hot water from the heater hitting, you're using to clean the coils. Cuts the grease real nice, man, but it does add to the heat when you're kicking it back on.
So you can change that to cold almost?
Yeah, if it works. Sometimes I've been showing photos to my PM team. I'm like, if you go on the roof and you turn the spigot on the wall and it's not, go downstairs, check by the washing machine and the dryer, and you'll see a spigot by the mop sink. Pop it open just like an old school shower, turn it one way, go up there and check, turn it the other way, go in there and check. You'll see that it'll one way might kill it all the way and it's only on one side, or you can go hot to cold. It runs the same way. It's in the older,
keep that in mind,
buildings.
I'll
shoot you some pictures that I
they're
have.
A lifesaver.
Yeah,
but I've seen them, where it's like steaming hot water, and I'm like, I'm gonna use it because I need to get this condenser clean. But then it's like, now you gotta wait before you even fire the thing.
Yeah, it'd be nicer to have cooler water, especially when you already had head pressure tripping and it's hot outside.
Yeah,
nice. Okay, so Brett's got a couple good points here. He says, what I suggest is that people should start doing is taking measurements on equipment that's working perfectly, so they have a reference point of what it should be doing. That's a great point. That way, when you come up, you already know what it should be. And then you apply back, check your subcooling, your temperature drop, check your superheat on the discharge line, superheat on the suction line, get accustomed to how it's been running. Yeah, great points, Brett. Especially on PMs. I don't like to, I'll measure all temperatures, everything, get a baseline. But yeah, that's all good points.
You know what? To his point about checking it when it's good and recording that information, that's great. I've learned over the years, if I've, an opportunity, if you have identical equipment. So I've worked on ice machines where there's a huge bin in a restaurant and there's two Manitowocks or two ice machines there, and one's acting up. I would always turn them both on, turn them back on at the same time, and watch them both. Watch the one that's working fine and time them out and look at the sequence of operations. And that's just a tip. If you have an identical model, you could always compare a good working one versus the one that's acting up. If you have multiple, especially in franchise restaurants, they have multiple of every model for everything they're doing there. But yeah, checking, recording measurements when it's new, that's awesome. That's helpful.
Yeah,
probably write it on the inside.
I've done that a lot, especially if I think the part is bad and I got the same machine right next to it. Check my reading across the part I think is bad, and then go to the machine that's working fine and compare the readings to it. Yeah, that's a great point.
And if
Yep.
you have multiple ice machines and they're both acting up, all of a sudden check what they have in common, whether it's power, whether it's water source. You got backed up water filters. It's like, why would they both be down? It's probably more relevant to restaurants because a lot of equipment runs off a reverse osmosis. The frappe machine, the steamers, the coffee machines, some of them use the same source of whether it's energy or water. And if they start all acting up, look for that common denominator.
So Dave Johnson brings a good
See,
point.
to that point,
Go ahead.
to that point, Jason. Sorry, Pat.
You good.
It's reminding me of it's rare that two of the same thing go bad, right? That's very rare. So always check what they have in common. And in the situation, it reminds me of years ago. I was running service calls, and then my boss had called me, and he's like, "Hey, I need you to go to this place." And they said that both of the fans on their walk-in cooler are down on the evaporator. And I'm like, both fans? He's like, yeah. I'm like, they sure that both fans are bad? Well, another company went out and said both fans were bad. And what ended up happening was that company said they had to order both of the fans. They were going to come back, but almost a week went by. They hadn't come back. They hadn't heard from them. I guess they had been calling them that day, to find out where they were coming. And when they couldn't get a hold of them, they called us. And I'm like, I mean, I'll make sure I grab two fans from the supply house. They're pretty standard. But, of course, I'm going to troubleshoot it myself. Long story short, they ended up having a bad neutral line on the power going to the two fans. Because I was like, there's no way. I mean, it can be that both fans are bad, but what's the chances? Now, what was funny is as I'm replacing the neutral line, that company walks in with two techs and two fans, and they're like, yeah, you got it running already? I'm like, yeah, it was a bad neutral line. But, yeah, that's a good point. Always check for the common denominator because it's rare, unless it's like some places where they'll let two fans out of three go bad before they call in the service call. It's rare that, but it's rare that two of the same things are going to start having trouble at the same time, and it's not going to be something that they have in common, like a power supply or water supply or whatever.
Yep. So Dave Johnson brought up a point. He said commissioning info for a baseline data point. So if you install a new, say if you're doing a walk-in, you get a new evaporator condenser unit, you're going to measure amp draw. You're going to know what charge you put in there. On the inside cover, write all the information down there, right? Compressor amp draw, your condenser fan motor amp draw, your charge, that kind of stuff. Put all the information in there. So, you may not be the next guy to come back, but guess what? If you are the next guy to come back 3 years down the road, you're not going to remember the amp draw. But if you got it written on the inside panel, hey, that compressor's pulling high amps, that compressor's pulling low amps. That fan motor, it's stopping pretty fast when it shuts off. And it's pulling high amps. Maybe it has a bad bearing going out. So all that information just helps you, diagnose a little easier and a little better. So,
well, we all use GE, and when I commission anything, I take that commissioning paperwork, that warranty paperwork, and I put it in the file room. And you could always go back to the history of that piece of equipment. I mean, I wish everyone did that, but that's a processy thing. But you should always.
That's a good point. I need to start doing that.
Oh, the file room. You could put pictures, videos, and files. And I like putting manuals that I can't get off of like Partstown, and that if I had to call the tech support and they send me a manual, and I know I went through all the trouble to find it, it goes in the file room for myself or for the next guy.
Yeah, nice.
So when I do a startup, I attach it to the file room for that piece of equipment too in Global Edge, because there's a file room you can attach just for that equipment, and there's a file room for the call. So I try to tie it to that piece of equipment so it's there in the future. Oh no!
Yeah, I try to attach everything to the equipment.
What just happened?
Time to change webcams. I guess it didn't like that. It died.
We can hear you though.
I say, well, this is awkward.
Well, there's your sign. Stage left. Well, it's the El Chupacabra and Jason show.
We did that on purpose, y'all. We kicked Pat out of here.
Yeah, I'm taking over. The inmates are running the asylum now.
So what else you got for us, Jason? Talk about refrigeration PMs. Since you're the plant maintenance manager, talk about refrigeration PMs. The best practices and also the common missteps that you see in them.
Well, for the most part, I mean, I like PMs because it teaches people the sequence of operations is, and if a piece of equipment is already working fine, you should always take readings before you start doing anything. In my opinion, even with the coil dirty, the belt the way it is, I check amp draws, I check everything the way it is. Then I clean it. I check my amps. I check the condition of the contactors, the capacitors, the fans and everything. And then I clean everything. I change the filters. I change the belts. I clear those drain lines. And then I check everything again and I compare it. And you can, if anything, you're making it better, but you can at least show the customer and have for history and data related that, this is what the unit has gone through since the last time we were here. Not everyone's on a quarterly schedule. Some people are on biannual, like twice a year. And, you just, you don't want to go quick to not capturing that information because you're not going to know what's really wrong with the unit. You're there to, better inform the customer and catch things before they happen. But if you just go to cleaning and just changing everything out, you're not going to really understand, what the unit is doing. So pitfalls, just take your time and understand what's going on and just be careful.
Nice.
Sweet. So I like this comment. Digital temp controls versus mechanical for reach-ins, pros and cons. I prefer digital.
I prefer digital if I can.
I have no cons to digital. I mean, it's funny because if you look me up in the restaurant equipment tech group, whatever it's called, for restaurant equipment, whatever, I had a lot of pictures a few years ago of literally taking out mechanical control, even on reach-in boxes and prep coolers, and replacing them with Dixel digital controls. I actually got called a hack for doing that, but which I thought was funny as hell. But I don't see any cons to digital controls. I feel like they're more reliable. They last longer. You can program an exact temperature you want it to run at. So it can be off at 35, on at 39. You can put in as many air defrost, or if it's, a freezer, as many, electrical defrost as you want. I don't see any cons to them. And especially my favorite digital control, I guess all around that works on reach-ins and on some walk-in applications are the Dixel XR controls. Now I know there's, I guess KE2s and other stuff that are also good, but as an overall workhorse control, I love the Dixel XR controls.
I'm a KE2.
I'm a KE2. If you got an opening, you can put that Dixel XR control in, that's good. But most of the time on, some of these reach-ins, they don't have an opening. You fit that in. You have to cut an opening.
So what's cool is Dixel actually has a mounting box. I know that before they sold to Emerson, the part number was CBOX for control box, and that's how I used to mount them on a lot of these old units. It's got a cutout on it. It's a good size box where you could run wiring in and out of it. And I mean, I've installed an insane amount of them. And we used to charge the company I worked for. It was like double the price of a mechanical control. But every time I went to a customer and said, look, I'm probably going to be back in a year and a half changing this mechanical. You're probably not going to see me for a while with this digital. They were like, do it. We don't want to see you again unless we have to.
Yeah, it pays for itself in service.
Oh, yeah.
Or lack of, the need for service.
Exactly.
So I had it wasn't a new box. I installed a new evaporator condenser, new lines, everything, hard piped it, in the ceiling insulated. I mean, I spent like a couple of days doing this job. It was a school and they wanted it done this way, so I did it. It looked great. It was a fun job. But this thing, in like a year and a half, it ate like 3 pin controls, dude, just the mechanical. And finally, I was like, look, I'm sick of doing this, guys. I said, we're going to spend a little extra money. I'm going to get you a KE2. We stuck it in there. You can see it in the back. Nice, bright display. You can open the door. You can see temperature. You can tell it's running. And never had another problem. It's been like 4 years.
Yeah.
I'm like, I don't know why that thing was eating those pin controls, but it just ate them up, man.
Yeah, those there's a bread soup place that everyone goes to here in Florida, and their walk-in cooler, they kept putting in those you put the butter knife in the Ping and Johnson control, and I don't know if they're just screwing those suckers to the wall too tightly that it warps, but you can't dial in the differential on those things. It's just too much of a swing. And they kept getting changed out. So I eventually, before I found KE2, I put one of what looks similar. It's a Ranco, if I'm saying that correctly.
Yep.
And I put that in there 4 years ago, and no one's been back in there since, at least not for control related issues.
Yeah.
And it's like ever since then, those are $50 still now, they're cheap. they don't have the air defrost in the ones that I was putting in, but that I was sold from there on out to just go to digital for the cost of not having to come back all the time and the service. I mean, one of those things, $250, that's a service call before you find anything with the hour minimum and the travel and the trip and the gas, the fuel and everything and the miscellaneous. It's just put that in there, and it's several trips that you're going to save. You're going to save thousands of dollars.
Oh, 100%.
The thing is, because if you keep going back, you're the one that looks bad, even though it's a jump.
Exactly.
It's not the controller they're looking at. They're looking at you. They're looking at Casper's. They're looking at Whaley's. They're looking at General Parts. It's not Payne Controls or Johnson Controls or whoever makes that. It's you. So you have the bad look in their eye. It may cost a little more that first time, but it's going to cost you less in the long run of eating callbacks and everything else to the customer to buy it up front.
Yeah, which I think is an important thing that technicians need to keep in their mind. A lot of times you've got guys like us, obviously, that want to give the best to the customer, but then you've got guys, especially if they're on their own, that, well, let me put in this cheaper thing so I can get more calls because I know it's going to fail at some point. You just look like a piece of crap to your customer when you have to keep coming out every 6 months to a year, to replace the defective control. So one thing I think techs need to constantly focus on is what's going to save the customer the most money in the long run. And what I like to do is, I give the customer the option. I'm like, hey, look, this will save you $200 right now, but in the long run, you're going to replace this thing 4 times before we ever replace this one that, is a couple $100 more now. But yeah, always approach every call with what's going to save the customer the most in the long run and present that to them.
The customer would rather pay $250 for a temp control than $5,000 to $10,000 in wasted food.
Yeah, exactly.
And not just someone trying to make more money off the customer. I've actually heard just as 50% to that is it's just easier to put it in because it's 2 wires. Yeah, you have to read the schematic and run additional wire. Make sure you have to control the solenoid and run power over, but it's just read it. It may instead of taking 10 minutes to put in that mechanical one, just spend 30 minutes, 45 minutes and just put it in there. Put it in there real nice. Run some extra J cord and you can make it look really nice and you're good to go.
And then the more you do it, the faster it gets. And before you know it, you're putting in that digital one in 10 minutes anyway. Yeah. You're like, I know I need this, and this. I need this much wire. They go here, here, and here, and I'm good to go.
Yeah, either a piece of J cord or some seal tie and some wire. I mean, there's tons of different ways to do it, dude. If you know you're doing it, you can make up the one end ahead of time. You can have it laid in the control. All you gotta do is mount the control and then run your wire into your box and tie it in there, and you're good to go. I mean, it's not hard to do. I mean, the first couple, you may be like, oh, what do I gotta do? But really, all you need is a neutral or a.
You guys ever prep your stuff like that?
I try to.
Oh man, the 100 series Henny Penny high limits. I used to take them out of the box and build them and add the 2 wires and put them back in the box.
I used to do that when I used to do a lot of the mechanical controls, taking them out of like the prep coolers and stuff and putting in the Dixel. I did so many of them. I knew exactly how many wires I needed, where they needed to go, and that's exactly what I would do. I have the box drilled out already. I have wire coming out of it, and then all I had to do was get there, put some butt connectors on the wires, and then go. Before you knew it, it wasn't taking me much longer than it would take to replace the mechanical with another mechanical.
So thanks, Quentin. Quentin says not kissing ass or anything, but this is coming his favorite podcast live. Something to look forward to near the end of the week. We appreciate it, man.
Cool, man. Thank you.
Yeah, we ought to have one sometime talk about being a small business owner and some of the adversities and stuff you got dealing with bigger companies like us. I support everybody, man. There's a place in the market for small, big individuals, whatever, man. There's always going to be a need for guys in this industry. So.
Oh yeah, it's not going away anytime soon.
Man, Pat, when you said about, the embarrassment of coming back several times, it's, there's a whole other thing to that. What about when you are legitimately having trouble with a call and, you're stumped, and you're asking for help and you're just not really getting it, but you keep getting sent back. Does that make you feel any kind of way? It's just like, could you please send somebody else and get another set of eyes or send someone with me so that don't have to continue. I mean, I'm not, I'll say it, sometimes you get stomped, we're not all, no one's perfect, and you get caught up on stuff. And I mean, I've just remembered in the past where it's just like, man, I've been sent back on this 3 times. I really need help. Send a supervisor, send a friend, phone a friend, or send someone else.
Yeah, I'm generally that guy to go out. There's no one coming to save me, it seems like.
Yeah, especially I guess if you're in a smaller branch, it's like you're all.
Yeah.
Yeah, unfortunately for me, there's only a handful of guys at my branch that can rescue me, and honestly, it's probably 2 guys, and one, me and him are basically on the same level. Me and him will run stuff by each other whenever either one of us are stuck. And then we got one guy that, I mean, he's really good on hot side. So if I get on a jam, especially like on a rationale or something, I can call him, and he's like, yeah, look at this, look at that, look at the other, and he's good to go. But yeah, I've been there. Like, I've literally sent my supervisor emails like, bro, this is my 5th time. I don't understand how this thing works. Please send somebody else. And then I went the next day, and that calls back on my schedule.
Yeah, like, this customer's not feeling this.
Steven
forget that I'm not feeling it anymore.
Steven's got a good point. He says, have you seen any issues with digital controls failing due to poor power supply, brownout, surges, or electric noise coming back up to neutral? He sees a fair bit of that, especially with houses with bad generator solar installs. No, I really don't see that. I mean, occasionally you may get one on if someone's not paying attention and it gets on like an older place, it may have a high leg. It may not like that. So that's about the worst power issue I get on controllers is having hooked to a high leg.
Yeah, I've smoked some stuff out in the past, but that was always on me.
Yeah.
But I've never come up on one that's failed that was running, and then it failed on its own because of something like that. I haven't come across that.
Man, that's a whole nother episode right there. Run this shit. I better watch out saying that name. But mechanical TXP versus EEV, pros and cons. I don't have a whole ton of experience on the electronic, man. Most of mine's all mechanical. I've installed a few, and I think they're pretty cool. Just like anything else, though, those controllers can be susceptible to brownouts, power surges. They can lose, what type of refrigerant's in there. Or if you get a customer, you say if you're at a local burger place and there's a lot of teenagers in there, they get button happy and they know how to work a phone and find Google and they can find passwords to anything. And all of a sudden, next thing you know, your control thinks it's, a 448, 449 system versus a 404 system. So that's about the worst I've seen with that. But I can't really speak enough to say 100%, pros and cons of each.
Yeah, with the EEVs, again, I didn't really mess with a lot of them until I got up here with Whaley, because we got quite a few accounts that's all they got. At first, I was like, man, this crap sucks, but it was mostly me not understanding them. The more I get to understand EEVs, I don't really see any cons to them. I would say maybe on the customer's end is, most people aren't stocking, the heads that go on them or anything like that as truck stock, where, it seems to be more common that you have power heads for regular TXVs on your truck. But even then, I don't even see them fail a whole. So right now, I don't see any cons. I mean, that's, 2 years of working with them. I can't think of any cons off the top of my head.
My experience with EEVs, the older ones that look like they look like dryers. I'm not going to say the brand because they've gotten better since then, but the spindle gets undone and you can't get it to reconnect. And those, we ended up chucking them out. Then they switched those egg-shaped ones to the brass teacup looking bell one. Those are better. And now they have the little Danfoss Jones, and those are really good. You can barely hear them stepping at all.
Mm-hmm.
I would say that the biggest issue I've noticed with EEVs is technicians who are used to TXVs. They're quick to try to charge things by the site glass. And if you do that with an EEV system, you're going to overcharge it every time. You don't use the site glass with an EEV system. You have to charge it in with your superheat and subcool every time. But when you see the notes and they say, I filled the sight glass, and I'm like, isn't that an electronic? What did you do? And then I'm like, all right, well, let's go pull everything out of there and let's do this. But if you're used to working with TXVs, and they shouldn't even do that from the get, I'm going to charge them sight glass. It's not a small reach-in, it's a walk-in. There's 10 to 17 pounds in this thing. You don't just go straight to just charging by the sight glass with an EEV. It's you're going to mess it up every time.
Sweet. Well, I think I'm gonna end it here, guys. It's been an hour and a half, and we could go.
Oh,
Has
wow.
it? Whoa.
Yeah. Yeah, it was a little slow at first. We kind of just took off there. So I appreciate the audience for stepping in. Some good questions. Good.
Yeah. Steven, welcome, man.
Yeah, he's
Great.
Yeah, that
great
was a lot of
input.
great info.
Looking forward to the next show with you, man. That was great input. Thank you.
he's
Everybody.
he runs a couple of residential sites, groups on Facebook. So I'll add you guys to
Cool.
it. We can get active in there. They have a lot of questions. A lot of those guys want to branch over to the commercial side, and I'll help you out any way I can. So, but
Excellent.
Yeah, yeah, me too, for sure.
I appreciate everybody joining in tonight, and have a good night, guys.
Y'all take it easy.
El Chupo, don't go nowhere.
If you guys would, please consider subscribing, rating, and reviewing the podcast. It really helps us grow and helps us know which direction to move in. Also, if you have any suggestions for guests, please email me at commercialkitchenchronicles@gmail.com. Or if you want to be a guest, email me. Love to have you guys on. Thanks a lot. See you next week.